As the title suggests, today in here you will learn how to use trig in a better way. So first, let's develop an easier way to remember what is trig. Trig unit circle. So we all know that how painful it is to remember the trig unit circle. Therefore, there is a faster way to remember it. First, you draw a bracket, and in the bracket you put 3, 2, and 1. On the next row, you put 1, 2, and 3. At the end, you'll put over 2. On the side, you will put cosine and sine. And on the top, you will put 30 degree, 45 degree, and 60 degree. So every time when you want to reference back what is sine 30, you will do 1 over 2. What is cosine 45? Cosine 45 is root 2 over 2, and so on and so on. And as for tangent, it is hidden in this graph. We all know that tangent is cosine, it is sine theta over cosine theta. And we can just do the simple math. Sine 30 over cosine 30, which is root 3 over 3. And sine 45, which is 1. And sine 60, which is root 3 over 2 divided by 1/2, which cancel out will be root 3. With a better way to remember the unit circle, I'm going to teach you what is trig inverse. Trig inverse, in Word, will be asking you something like this. Sine inverse of 1/2 is equal to what? So this might seem confusing at first, but if I put it another way, sine of what is equal to 1/2. So can you answer this question? Sine of what is equal to 1/2? You guessed it. It is sine 30 degree. And trig inverse is basically asking you what is the angle given the ratio. Therefore, every time if you get confused on a trig inverse problem, you can put in another way, which may help you learn it better. So let's do another practice problem. What is the cosine inverse of 30 degree? Oh, actually, no. Cosine 30 of root 3. With the unit circle you just learned, we will know cosine of 30 degree is root 3 over 2. Okay, so now let's go to do some harder questions. What is the arcsine of negative root 2 over 2? So you may ask, wait a minute, what is arcsine? So arcsine is actually just equal to sine inverse of negative root 2 over 2. And this question is hard because in this question, you have a negative value. So sine of 45 degree is root 2 over 2. However, according to the circle we learned that all ASTC is that all of them are positive here, and in this quadrant only sine is positive. In the third quadrant only tangent is positive. In the fourth quadrant only cosine is positive. So we all know it will never be here, nor it will be here, and it might only be here. So sine of negative root 2, 45, will be something like here. So sine 45, so this will be answer will equal to sine 45. Okay, so now I need to teach y'all another important thing. Cosine inverse of. In this question, you see that they are different by having an uppercase and a lowercase. In the uppercase, we all did the question before. The answer is 45 degree. However, if you have a lowercase, you will make it something like 45 degree plus 360n. Or you can say pi over 4 plus 2 pi n. Why? Because on a graph, which is an inverse graph, you will have something like this. On this graph, we will see from pi to 0, we'll have a workable graph. If we extend it all the way down to here, this will not be a graph because this cannot pass the straight line test. And this introduces the graph of arcsine. In an arcsine graph, the graph will behave like this. And this is pi over 2, and here is negative pi over 2. And so we know for the in this graph, the workable graph only appears y is less than and less than negative root 2 over pi over 2 pi over 2 and greater than negative pi over 2. So arcsine only works in quadrant 1 and 4 because pi over 2 is move up 90 degree and negative pi over 2 is go downward 90 degree. So only quadrant 1 and 4. After this, let's look at tangent graph. Arctan graph. In an arctangent graph, the graph will behave something like this. This graph, which is pi over 2 and negative pi over 2. this graph with the same properties of sine graph, this behave from pi over 2 to negative pi over 2. However, this has a really important thing, is that this graph is close to pi over 2 but never pi over 2. Same thing appears to here. Therefore, our tangent graph is negative pi over 2 is y is greater than negative pi over 2 but not greater or equal to pi over 2, and y is less than pi over 2. Okay, right now let's go back and sum up everything. Sine inverse graph only appears in quadrant 1 and 4, and so does tangent graph is in quadrant 1 and 4. Cosine graph appears in 1 and 2. So this might be hard to remember. However, there's actually an easier way, once again developed by myself, to remember this. Sine, we only need to remember that cosine in the word cos, the s looks like a 2. Therefore, you can tell you that every single graph all appears in quadrant 1. However, only cosine graph only appears in quadrant 1 and 2. Okay, so now let's really get into some harder questions. What is the cosine inverse of cosine 7 pi over 4? So you may want to break this into two components, the cosine 7 pi over 4 and the bigger component. Let's focus on the smaller components first. What is the cosine, what does cosine 7 pi over 4 equal to? The cosine 7 pi over 4, you will know that it is just on the verge edge after one circle, which is something like here, which will be just equal to pi over 4. Pi over 4, what does cosine pi over 4 equal to? Pi over 4 is equal to root 2 over 2, ASTC, yes. And we can also use the ASTC to tell if this is a positive or a negative value. We all know that in this area, the C is positive. Therefore, this will be root 2 over 2. And now we can expand this question into cosine inverse of root 2 over 2. Cosine inverse of root 2 over 2, what is it? What is cosine of what is equal to root 2 over 2? And now, with the unit circle and the easier way to remember, you can tell me that cosine root 2 over 2 is 45 degrees, because you're looking for a positive value. If it'll be something like this, like negative value, you'll be looking at this negative 45 degrees. So now let's look at another problem. tangent of sine inverse of 3/5. This is a calculator problem. So first, we will want to find out this is a non-calculator question actually. So you will want to first draw a unit circle, or I mean just a graph. Sine of theta, sine of something is equal to 3/5. Sine we know is so opposite over hypotenuse is 3/5, and then x. And what is x? X, if we use the Pythagorean theorem, because here you have a right angle triangle, it will be 5 squared minus 3 squared over, oh, there's no over, root entire thing. It will be equal to 25 minus 9, which is 25 minus 9, which is 16. Root 16 is equal to 4. And with the same triangle, we will find tangent. Tangent, we all know is soka to so T opposite over adjacent. Tangent of that thing will be of sine 1/3/5 will be equal to 3/4. Now we are getting into a calculator problem. If I write arc of sine of 0.7263 on a calculator, you will type in sine inverse of, also one important thing is that remember to change your calculator to the right mode. It is a very common mistake that in your sophomore year that many people got a bad grade in a trig inverse function test because they forgot to change their calculator to radian mode or degree mode. And this we see that is a decimal, so which means it is a radian. And arc of sine, which is sine inverse of 0.7263 is equal to 0.8129237754, and we can approximate it to 0.8129. And since this is a lowercase, this will be 0.8129 plus 2 pi n. And in this question, there's actually another answer, because on a sine graph, it will be positive in 2 quadrants, which is quadrant 1 and 2. Therefore, 0.8129 is less than 1/2. This is less than power 2, so which means you can do 2 pi minus this answer, 5.8129 to get the degree in this area. Therefore, 2 pi, let's use the calculator again, 2 pi minus answer minus 0.8129, which is 5.47026. We can round that to 5.4703. 5.703 plus 2 pi n, because on the graph, on the inverse graph, would be something like this. This is just odd. And now I would like to show you a harder question. The sine of cosine inverse of x over 4. Does this sound familiar? Yes, and you guessed it. You will first draw a graph table. Cosine theta, we all know that SOHCAHTOA, ka is a over adjacent over hypotenuse, so ka is adjacent is x, hypotenuse is 4. And this, what is this line? What is the opposite side of the theta? So we also need to find that, because here we have a sign. So question mark is equal to, using the Pythagorean theorem, it will be 16 minus x squared. And you square the entire thing. Minus x squared. Now you would do sine of sine, we all know that is so opposite over hypotenuse, OB, sine of the entire chunk, we call it theta, OB, O, 16 minus x squared over hypotenuse, which is 4, and we get the answer. Sine of theta is equal to root 16 minus x squared over 4. And with having variables up here, it will bring us to learn how to solve equations, solve unknowns with solve trig inverse equations with a variable in it. So let's look at an example question. 2 is equal to 6 cosine 2x plus 5. This might look hard at first sight. However, after you learned like to do the basic stuff, this will be a pretty easy question. So if we use PEMDAS, we can first minus the get rid of the 5. So it'll be 2 minus 5, which is negative 3, is equal to 6 cosine 2x. And the next step, we can get rid of the 6. Therefore, we can do negative 3 over 6 is equal to cosine 2x. Which that's further simplified into negative 1/2. Okay, so does this look familiar in any sense? Yes, and this refers back up to the English I just taught, which is the trig function inverse, trig inverse, is actually asking trig of what ratio is equal to the angle. Therefore, in this question, this will be cosine of what is equal to -1/2. Therefore, now we can use the cosine inverse of -1/2 is equal to 2x. And the final step is to get rid of the 2. Therefore, we will do cosine inverse -1/2 over 2 is equal to x. And what is cosine inverse of -1/2? On -1/2, we all know that we want a negative value. Therefore, ASTC, it will only appear in this quadrant and this quadrant. Therefore, cosine of -1/2, which is 60 degrees, we want the negative value. Therefore, it will be 2/3 pi, which actually the better way to teach it would be, we want the angle here to be a 60 degree. So we will do 180 minus 60, which is 120. And we have a radians all along in this question. Therefore, we will have 2/3 pi. This is our first value, and we also need to plus 2 pi n because here we have a lowercase. And we just talk about, like in the third quadrant, we also have the negative value. Therefore, we'll need to do 180 plus 60 degree, which is 240 degree. And 240 degree will further get you into 4/3 pi. And we'll just do the same step, plus 2 pi n. Now, I would like to show you another, on this question, on these type of questions, the teacher usually asks you about what is, oh, actually, there's one important step I have forgotten, which is this has a over 2. Therefore, with these answers you need to divide it by 2. And now you will have 1/3 pi plus pi n and 2/3 pi plus pi n. These are your solution. Sometimes the questions might ask you, what are the values, what are the positive values? You will plug in 1 and in real number. You plug in real numbers in these brackets so that you will know so that you get the positive values of x. Okay, so now it's time to sum up everything we have learned so far. We learned how to get a faster way to remember the unit circle, which is 3, 2, 1 and 1, 2, 3. And this table is actually pretty quick to make, so during the exam you can write in like a very small corner Yes. And tangent is just basically cosine theta. Oh, it's just sine theta over cosine theta. So you will just do the math in the exam. We can actually just prove what the 1/2 divided by root 3 over 2, and now we'll have 1 over root 3, which is root 3 over 3 to make the denominator a rational value. And the second thing we learned was the ASTC graph. In the ASTC, if it is a lowercase, we know that in quadrant 1, all functions, all trig are positive. On the second quadrant, is only the sine is a positive value. In the third quadrant is only tangent is positive value. In the fourth quadrant, there's only cosine that has a positive value. And yes, and with an uppercase, which is cosine, sine, and tangent, we know that in cosine is all of them. And in second quadrant, what about you take a moment of guess to see, do you know what's the second quadrant? Yes, it is the cosine. And in here, if with uppercase, there's nothing here. Nothing in the third quadrant. And the sine or tangent exists in 4. So cosine is 1 and 2. Sine is 1 over 4. Tangent is also 1 over 4. And the cosine we have it easier to remember, which is the s. The s looks like a 2, so quadrant 1 and 2. And the last thing we learned is how to solve trig inverse with variables. And there's 2 types of them, which is something weird, tangent of cosine inverse of x over 3. When you see some question like this, you usually will want to just make this part onto a graph, and then you will start your thinking from there. And also, you need to remember the uppercase and lowercase, and this is actually really important. If you have lowercase, you will have 2 answers, or you can say 2 equations, which is something, or just something in radians, plus 2 pi and in uppercase, refer back to this graph, you only have something in these quadrant. The second type of question we learned are something like 4 is equal to 7 plus 4 sine 1/4 x minus 3 pi, something like that. And what you would like to do is to just get rid of these little pieces that can be used in PEMDAS, and you get rid of the 4 because it is multiplier. Now you will get rid, and then you can do sine inverse, and so on and so on. And thank you for watching this video, and I hope you all will have a good time in sophomore math.